Cement and steel production are responsible for roughly 14% of global CO2 emissions. That is more than aviation and shipping combined. And yet, fewer than 3% of construction materials in Europe carry a verified environmental declaration. So when a supplier tells you their concrete is low carbon, what does that actually mean? Today, we are going to dig into the data, separate real decarbonization from measurement theater, and show you exactly what sustainability leads and procurement teams should be tracking in 2026. Here is the headline. Starting in 2026, the EU's Carbon Border Adjustment Mechanism, or CBAM, is fully operational. That means carbon costs are now baked into every ton of imported cement, steel, and aluminium crossing into Europe. European producers already pay 80 to 100 euros per ton of CO2 under the emissions trading system. CBAM levels the playing field, but only if domestic producers can actually prove their carbon intensity is lower. This is not a theoretical policy discussion. McKinsey estimates that the green premium for low-carbon steel and cement could unlock 50 to 80 billion euros in annual value creation by 2030. But here is the catch. That value only flows to producers who can credibly demonstrate emissions reductions, not to those playing accounting games. Let us talk about the elephant in the room. Measurement. The primary tool for comparing materials is the Environmental Product Declaration, or EPD. An EPD is a standardized, third-party verified statement of a product's environmental impact across its life cycle. Sounds good in theory. In practice, quality varies wildly. A product-specific EPD based on actual factory data is accurate within 5 to 10%. An industry average EPD can diverge from actual product impacts by 50% or more. That is not a rounding error. That is the difference between genuine progress and a nice-looking PDF. So how do you spot a weak EPD? Here are 5 things to check. First, verification scope. Is it facility-specific data or generic industry averages? Second, system boundaries. Cradle to gate only covers production. Cradle to grave includes the full life cycle. Big difference. Third, electricity grid factors. A plant running on renewables in Norway looks very different from one on a coal-heavy grid in Poland, even if the process is identical. Fourth, benchmark reference. Is the claimed reduction measured against current best practice or an outdated baseline from 2005? And fifth, is the data from a real EPD or a marketing summary? Always request the underlying EPD document. Let us get into the materials, starting with cement. The global average carbon intensity sits around 620 kilograms of CO2 per ton of cement produced. Best available technology can push that down to roughly 520 kilograms. Leading producers like Heidelberg Materials are targeting below 400 kilograms per ton by 2030 through clinker substitution, alternative fuels, and carbon capture. The single most important number in cement decarbonization is the clinker-to-cement ratio. Clinker is the calcium silicate compound produced in the kiln. It is where the chemistry-driven CO2 comes from, and that process alone accounts for about 60% of cement's emissions. The rest comes from fuel combustion and electricity. Standard Portland cement has a clinker ratio around 90 to 95%. Blended cements using fly ash, slag, or calcined clay can get that down to 50 to 65%. This is where products like Holcim's EcoPact line operate. Here is a data point worth tracking. EcoPact premiums declined from 20% to just 8% between 2023 and 2025 as production scaled. Green premiums are compressing fast. Now, can you go further? Carbon capture, utilization, and storage or CCUS, is the big bet for getting cement below 400 kilograms per ton. Heidelberg Materials is operating pilot CCUS facilities, but this technology is still pre-commercial at scale. Be skeptical of any cement producer claiming near-zero emissions today unless they can show you verified CCUS operational data. The honest answer is that truly near-zero cement is still 5 to 10 years away from mass deployment. Steel is a different story. There are two primary production routes, and they have very different carbon profiles. The blast furnace and basic oxygen furnace route, known as BF-BOF, runs on coal-derived coke and produces roughly 1.8 to 2.2 tons of CO2 per ton of steel. The electric arc furnace route, or EAF, melts scrap steel using electricity and sits around 0.3 to 0.6 tons of CO2 per ton. That is an 80% difference in carbon intensity depending on which route you are buying from. The frontier technology for steel is hydrogen-based direct reduced iron, or H2DRI. This replaces coal with green hydrogen as the reducing agent, potentially cutting emissions by over 90% compared to blast furnace steel. SSAB's Hybrid project and H2 Green Steel in Sweden are the furthest along, with commercial-scale production expected between 2026 and 2028. But let us be honest about the premium. Near-zero hydrogen-based steel carries a 30 to 50% cost premium right now. High recycled content EAF steel is more affordable at a 10 to 20% premium. And for many structural applications, it delivers significant carbon savings without the bleeding-edge price tag. For procurement teams, the practical question is, what do I actually buy in 2026? Start with EAF steel with high recycled content. Demand responsible steel certification for chain of custody verification. For projects where you need primary steel, ask for facility-specific EPDs and compare against the BF-BOF average of 1.8 to 2.2 tons CO2. Any supplier claiming green steel without a verified EPD should trigger immediate scrutiny. Now, timber. Engineered timber products like cross-laminated timber, or CLT, and glue-laminated timber, or glulam, represent a fundamentally different decarbonization pathway. Unlike cement and steel, timber sequesters carbon during growth. 1 cubic meter of wood stores roughly 900 kilograms of CO2. But, and this is important, that sequestration only counts if the forest is sustainably managed and the timber stays in use long enough to matter. This is where things get complicated. Biogenic carbon accounting, meaning the carbon stored in biological materials, is one of the most contested areas in life cycle assessment. Some producers claim timber buildings are carbon negative, but that framing can be misleading. If you harvest a forest faster than it regrows, or if the building is demolished and the timber burns in 30 years, the carbon math changes entirely. Look for FSC or PEFC certification for sustainable sourcing. And be cautious about any carbon-negative claim that does not account for end-of-life scenarios. The emerging SBTI flag guidance is starting to bring rigor to this space, but we are not there yet. Here is the good news for timber. On a structural weight basis, engineered timber typically carries no green premium compared to steel concrete equivalents. The cost difference shifts to design. Timber requires different engineering approaches, different fire protection strategies, and different supply chain relationships. For mid-rise construction, roughly 5 to 15 stories, CLT and hybrid timber concrete systems are increasingly cost-competitive and can deliver 40 to 60% reductions in embodied carbon. Let us zoom out and talk about green premiums across all three materials. For concrete achieving a 30% carbon reduction, expect a 5 to 10% cost premium. For 50 to 70% reduction, that jumps to 15 to 25%. For steel, high recycled content EAF runs 10 to 20% premium. Near zero H2DRI steel is 30 to 50% premium. Timber, as we said, is roughly at parity on structural weight. Now here is the critical insight. These premiums are shrinking, and once you factor in CBAM-adjusted import costs, by 2027 conventional imported materials may actually cost more than premium domestic low-carbon alternatives. Budget green material premiums as 2 to 5% of total construction cost for a 30 to 40% embodied carbon reduction. That is typically the most cost-effective decarbonization available at scale. Let us talk about why this matters beyond just materials costs. For new buildings meeting current energy codes, the embodied carbon from materials typically equals 30 to 50 years of operational emissions. Read that again. The carbon baked into your building at construction is equivalent to decades of running it. For net zero energy buildings, embodied carbon dominates, often exceeding 70% of the total 50-year life cycle emissions. This means material selection has become as important as energy efficiency for minimizing whole-life carbon. For sustainability leads, the implication is clear. Scope 3. Category 1 emissions from purchased construction materials need the same strategic attention you have been giving to operational energy. Let me walk you through the regulatory timeline because it is moving faster than most organizations realize. 2026. CBAM is fully operational. Carbon costs on imported cement, steel, and aluminium are now real line items. 2027. The EU Construction Products Regulation. Update mandates digital product passports with granular environmental data for all structural materials. Also in 2027 and beyond, the Corporate Sustainability Due Diligence Directive extends liability for supply chain emissions to purchasers. That means if your supplier's carbon data is wrong, you are on the hook too. So how do you avoid what we are calling measurement theater? Here is a practical framework. Step 1. Require product-specific EPDs for all structural materials above a spend threshold. Industry average EPDs are a starting point, not an end point. Step 2. Compare carbon intensities against sector benchmarks. For cement, compare against the 620 kg per ton global average. For steel, compare against 1.8 to 2.2 for BF-BOF or 0.3 to 0.6 for EAF. If a supplier's number looks too good, ask how they measured it. Step 3. Be deeply skeptical of carbon-neutral claims achieved primarily through offsets rather than production process changes. Offsets have their place, but they are not the same as actually decarbonizing a kiln or a furnace. Step 4. Check whether claimed reductions are measured against current best practice or outdated baselines. A 30% reduction from a 2010 baseline might mean they are still above today's average. Step 5. Request underlying data, not marketing summaries. A credible supplier will share their EPDs, their verification methodology, and their emissions trajectory. If they resist transparency, that tells you something. Think about data quality as a hierarchy. At the top, you have facility-specific, third-party verified EPDs with cradle-to-grave boundaries. Below that, product-specific EPDs with cradle-to-gate boundaries. Then industry-average EPDs from recognized databases. Then supplier self-declarations without verification. And at the bottom, no data at all. Most of the market is still operating in the bottom two tiers. Moving your supply chain up this hierarchy is arguably the highest impact action a sustainability lead can take in 2026. Who wins and who loses in this landscape? Winners, producers with verified low carbon intensity and transparent data. Heidelberg Materials, Holcim, SSAB, and H2 Green Steel are positioning aggressively. Procurement teams that build EPD literacy and set carbon specifications early will lock in supply advantages. Losers: producers relying on unverified claims or offset-heavy strategies. Organizations that delay building Scope 3 measurement capability face regulatory exposure and stranded supplier relationships. The middle ground is disappearing. As CBAM tightens and digital product passports become mandatory, the gap between leaders and laggards will widen into a chasm. Here is your action plan for the next 12 months. First, audit your current material specifications. Do they reference specific carbon intensity thresholds? If not, set them using the benchmarks we discussed today. Second, map your Scope 3 Category 1 emissions from construction materials. You cannot manage what you do not measure. Third, require product-specific EPDs from your top suppliers by volume. Give them a timeline and make it a contractual requirement for new tenders. Fourth, build internal EPD literacy. Your procurement team needs to read these documents, not just file them. Fifth, model CBAM adjusted costs for your key materials. The economics of green premiums look very different when you factor in carbon border costs. A quick reference on standards. For EPD methodology, reference EN 15804 plus A2. For carbon footprint quantification, ISO 14067. For construction product sustainability, ISO 21930. For cement, track the GCCA 2050 Net Zero Roadmap targets. For steel, look at Responsible Steel certification. For timber, FSC or PEFC certification plus timber-specific EPDs. Set your specifications against these standards, not proprietary methodologies. It ensures comparability and reduces your verification burden. Let me leave you with one number. Fewer than 3% of construction materials in Europe carry verified EPDs. That is the measurement gap. It is where greenwashing thrives, and it is where genuine progress gets buried. Closing that gap is not glamorous work. It is spreadsheets, specifications, and difficult conversations with suppliers. But it is the work that separates organizations making real progress from those producing sustainability reports, full of aspirational language and questionable offsets. The data exists. The standards exist. The regulatory pressure is here. The question is whether your organization will be the one verifying or the one being verified. Thanks for watching. Links to all sources are in the description. Drop a comment if you want us to go deeper on any of these materials.